So we'll continue with Roy Keene from Nightpoint, and he's going to talk about software-defined network with OpenNebula.
Roy, and I'm an OpenNebula user. I've got a real short presentation here about software-defined networking with OpenNebula, and it's about 4 slides. I'm hoping most of the time will be filled with, interaction with you guys. So if you have any questions, feel free to interrupt. I'm going to go through the slides pretty slowly and just talk and talk until someone interrupts me. So that's a fair warning. I work for Nightpoint Systems, and we use OpenNebula for various things. And one of the things we do is software-defined networking. And the main thing that we do with software-defined networking is to bridge the gap. We have a lot of legacy customers. We're technically a cloud provider, but a lot of people want to just run VMs all the time. And they're going to want to run VMs they already have, in that case, most of the time. So they're going to have legacy network requirements, and they're going to want to be able to configure their networking themselves and how they want. And they don't want to have to create a specification and get that to us. And they want their network engineers to be able to be in control of it, even in our public cloud. So this is a way to get some networking that the customers can use and configure themselves without giving them access to create any VLAN they want, or manage any VLAN they want, or interfere with other tenants and the multi-tenant public clouds that we offer. Yeah. It's software-defined networking. This actually is a twofer, and we'll get into that in a second. But so you're really getting your money's worth on this presentation. We're going to talk about software-defined networking and a general method we make for these small appliances. It's just a switch that you have an API for. That's all we're talking about. It has a fancy title, software-defined networking, but really this is just an API for configuring a virtual switch that the tenant maintains in their space, so they can do VLANs and without any interaction with the administrators or even knowledge of without the knowledge of the administrators. So obviously OpenNebula already has virtual networks, which lets you do software-defined networking if you're an OpenNebula administrator, but not if you're just someone on the cloud. You have to request those through some out-of-band means and do that. And also, the other thing we do with this particular thing is allow you to plug in cables far away without the actual cable. So distant networks, they're distant, but we can abstract that concept away. Like I said, legacy and migration is a big thing for us as a company, and so that's one reason we have this. Odd networking requirements is another thing. We run our OpenStack solution uses VLANs for segregating storage from net compute. And so when we want to run our OpenNebula solution on top of our existing public cloud, we need to have some way to do VLANs rather than creating tons and tons of VLANs as an administrator. And then again, plugging in a cable from all the way across the world. So how does it work? It's real simple. OpenNebula already has an API. We don't try to create a new endpoint. Instead, you talk to the OpenNebula XML RPC endpoint, and you can set the user template, the user attributes on that running VM, and OpenNebula already has access control and users and all of these other things. You can store this information there, and then the virtual appliance will go and read those. It'll compile them into a configuration, evaluate that configuration with respect to the current configuration, and then apply the differences so that running system is actually as the user requested it, no matter what its previous state was, and then keep doing this over and over again until you're tired of it. You kill the machine. So this is a general purpose paradigm. It's not quite as easy to pronounce as REPL, but We have other virtual appliances that do this exact same thing. Read, compile, evaluate, apply, and loop. So we have a load balancer that reads from the OpenNebula user attributes a base64 encoded zlib compressed JSON blob that tells it exactly how to configure that load balancer. And this particular API is also very helpful because of one flow. When you are adding a load balancer to a service, you want other systems in that service to be able to configure it. And this lets you do that in various ways. You can make it as part of the service template for one flow. You can set here's the static load balancer config. Say connect to the role for the web tier or the role named web, and the load balancer will go and talk to one gate and one flow and figure out that the web role has these VMs, and it'll set up the configuration, which is just HA proxy. It'll go out, obtain SSL certificates if you want it to, but all that configuration is just an attribute in OpenNebula for the load balancer VM that is created by either the service template or some other VM as part of the service can go and set that. So you can have, say you want to have a little bit more control and generate the configuration dynamically when some other role, some other VM in the service template instantiates itself, it'll go out and actually set that attribute and configure it. That's the end of my slides. I was really hoping someone would interrupt before we got here, but we also, I can keep talking. The same paradigm, the same solution here we use for, well, these are the laser pointer, the R seal, whatever you want, however you would like to pronounce it. If anyone has a pronounceable version, we have a SSH jump box. So sometimes we want people to be able to get to their various things through an SSH server. It's completely, our architecture is usually stateless, so the disks, are the appliance we use for all of these things is a read-only disk with TempFS overlaid onto it, so that it looks like our other systems, which run out of TempFS all the time. So overlay FS to TempFS. So they're very, very stateless, but you can create users using OpenNebula attributes, and you create those users in OpenNebula, and it'll actually create them on the box, put their public keys in their authorized keys file, and they can just SSH in. If you need to recycle that box, yeah.
Oh, just curious, I want to interrupt that. So your environment,
Mm-hmm.
Are you running multiple tenants on the same cluster?
Yes. Yeah, so we have, we use VDCs and we use clusters, and the VDCs are really just an interface to ACLs. So we have clusters for some things. We have multiple actual instances of OpenNebula, and then VDCs usually within those instances to represent a tenant, and then groups within that VDC to represent different people, different groups of people from that customer or that tenant.
When we were talking last night, you mentioned that some of your customers are FedRAMP moderate.
Right. We have, yeah.
Is
So
that on the multi-tenant platform?
yes.
Oh, that's awesome.
Yeah, right now we run public cloud, technically for OpenNebula instances. We have data centers in Ashburn, Virginia, and Santa Clara, California, and at each of those data centers we run a commercial and a federal instance, and on the federal instance those are right now FedRAMP moderate, we're going FedRAMP high, and the DISA SRG or 4, we're going DISA SRG 5, and those are all multi-tenant, just normal public clouds like Amazon GovCloud.
So when you're running a single VLAN and a single cluster, how many tenants can you get on a single VLAN? Are they hidden from each other, or do you have to spin a new VLAN for each tenant?
So the tenants in the vSwitch, the tenants can create the VLANs themselves. We're just providing, as a virtual network, a way for packets to get, Ethernet frames to get from place to place.
That's like the inverse problem of going for on my VLAN ID, one per instance.
Mm-hmm. Yeah, so instead of that, you have 4,094 VLANs as the provider, but each virtual network can then take 4,094, 4,095 with the untagged VLAN, and you can, on every network, the tenants can assign their own IDs the provider, as you as the provider would never even know if they did this, other than if you were using hardware that tried to look at this, because it becomes 80. We're using Linux bridging here for the back end, and it'll convert the 802.1q frames into 802.1 AD, which is Q and Q. So if your switches on the other side don't handle 802.1 AD correctly, then you'll have some problems. But you could also use, the tenant, the user is unaware of the back end, so they don't know that you're doing VLANs or VXLANs or whatever actually you're doing. As long as the virtual network acts like a virtual network in OpenNebula, it'll continue to work. And
So the VLANs are software-defined VLANs, they're not,
right.
the switch doesn't know anything about it.
The infrastructure suite, the core switches of the infrastructure don't know anything about it. They only exist in software. Yeah, Ethernet frames. So it makes it easier, especially if you're deployed as part of a service template. You're like, I want my network stack to look like this. Your network stack will look exactly like this, no matter what the back-end infrastructure looks like. You can use the same VLAN IDs over and over again on different networks, and there's no problem because the frames never interact with each other. So this is actually a really short script. It's about 200 lines. It just goes out and reads the configuration, runs IP and bridge, because you're going to have tagged VLANs and untagged VLANs. So it say F0 is native VLAN is 65, and VLANs are 65, 66, 67. Anything, and then you can say Eth1 is native VLAN 67. So anything coming in Eth1 will be tagged with VLAN ID 67 and go out Eth0 with that tag, just like a normal switch. You just don't, the plane, they're separated, the data plane and the control plane. They don't really resemble each other at all. In fact, they're separated by a script and about 5 minutes of latency. It goes out, yes.
Where is this downloadable from the marketplace, this Netpoint Systems VM?
No, I'm trying to get this. It's the easiest way would be just to use the script, which is about 200 lines long. I'm trying to get it pushed through my company and get it released. I was hoping to have it done already, but I ran into some other problems. And but the main part of it, I mean, the actual implementation itself is very simple. Just read these attributes, look at the stuff you get from one gate to identify what physical interface is Eth0, because they may differ. So you get the MAC address from one gate, and you say, okay, OpenNebula thinks Eth0 has this MAC address. What interface has this MAC address? And then you get the user attribute says Eth0 underscore native underscore VLAN equals blah, and then Eth0 underscore VLANs equals blah, and just actually run IP and bridge to set that stuff up. I'll pass that on to the OpenNebula guys, and they'll probably post it along with this stuff if I can get it, when I get it done, hopefully the next couple of days. The other part is hiding the fact that distant networks are distant. So that one's a little bit more complicated, and it's not actually complete, so I didn't put a lot of information on it here. But we use a VPN technology that is automatic full mesh. It's called Tink. It's open source. And the part of the vSwitch template is you can say, hey, these nodes are participating in this switch across the world. And so the individual switches will learn about each other and learn about their public keys. It's asymmetric crypto. So they'll learn about the public keys from themselves and generate the direct paths, even if both sides are behind NAT, using a system that's double NAT traversal system, similar to Turn, but a little more aggressive in getting those UDP packets going in both directions. And ultimately, what you end up with is a cable, essentially. So you can plug this cable, this virtual cable into this virtual switch on one side, this virtual cable into this switch on the other side, and now you can span your broadcast domain over as large a distance as you want just by essentially plugging in a cable. But it's going over a VPN. You're not aware of these things because all you're doing is providing the definition of how this should happen. And there's a pairing process with the VPN stuff. Let's see. Yeah.
Do you spin up this appliance as a regular VM, or are you using the virtual routing framework?
This is right now a regular VM because it doesn't do any layer 3 stuff. And so it doesn't know about this layer, the vRouter stuff. I'm going to extend it because I was actually wanting a virtual router before you guys release that stuff. And so I was going to make a separate template to do that, but it didn't make any sense because it needed to do all the same things. It still needed to be a switch, but it also needed to be a router, just like a real router usually has a switch underneath it. So the plan is to add layer 3 support eventually, and then since the vRouter stuff exists, you know, you can set vRouter equals yes, and it'll know to consume those attributes as well. Yeah.
Would you be able to replicate that VM, say, from Alexandria to Santa Clara?
Mm-hmm.
And does the network environment support bringing it up and having the exact same result?
Yeah, because the layer 2 it works the same way. So you replicating, it's not part of the vSwitch, but you know the data is replicated on the back end periodically. We have a scheduled snapshots that replicate hourly, or you know however the user sets it, replicates between the two data centers, and then as well as archiving in Glacier.
So if a customer wanted to run coast to coast, they could make configuration changes on the East Coast and then.
Right, and they could have VMs. In fact, one of the reasons I created this and I'm using it is because I have a instance of our OpenNebula cluster running in Santa Clara, and the people who want to use it are in Ashburn, and they're actually talking just over the same network. They don't realize they're just talking Ethernet to each other. They don't realize that they're traversing a network that spans half the U.S. or spans the U.S. because they're on the same broadcast domain. You know, ARP works, so they can say ARP who has the IP address of the OpenNebula node, and here it is. And then they're able to talk IP to it after that.
Oh, so you've got stretch layer 2?
Right. Yeah. That's provides stretch layer 2.
Okay.
And automatically, it's just a cable, a virtual cable. Stretches layer 2 because this is a virtual switch. I have the virtual switch running on each side, and the VPN meeting in the middle, acting as a cable. So, but yeah, this was just a real short project that had a lot of things, especially it was one of our first projects that used this particular idiom of read, compile, evaluate, apply, and loop, and that's been really helpful because we don't have to define a new API endpoint for every application we create, especially because the networking device here, layer 2, doesn't have an IP address. You know, if you wanted to connect to it, you have to figure out how you're going to get to it. It doesn't. There's no reason it would need an IP address. It's a switch. So, that's why I came to the conclusion we should, just use one gate. We're already talking to one gate through a different mechanism. Through the way our stuff works, it's tricky, but it can always talk to one gate. And so, if you talk to OpenNebula, one gate talks to OpenNebula and bridges everything together for you, so you get an API without any endpoints. It's serverless, if you will.
I'm having trouble understanding how the interface works for the user. Like, this is, actually I'm not understanding exactly where I come missing here. You want to do layer 2 networks for your users.
Yeah.
This is reserved for administrators and the general OpenNebula workflow. So if I'm a user, what do I need to do do this with your extension?
So the administrator doesn't need to really do anything except provide networks. They can be really the ideal of situations that they're Ethernet networks, and then the user says, okay, I've got all these networks. Lets me plug them in as cables, as interfaces to the vSwitch, and then I can overlay my desired network topology with my desired VLAN IDs. I can do VLAN tagging on some of them and not all of them. And I can say this network goes to my VLAN 64. This network goes to my VLAN 65. This network has tagged VLAN 64, but it's untagged VLAN 10. And so the user, without any interaction with the administrator other than being provided those Ethernet networks, spins up the vSwitch virtual appliance and sets user attributes, or he can change them at runtime to say those particular things. And eth0_native_VLAN equals 64, eth0_VLANs equals a list of any VLANs they want. And so it's actually just using Linux bridging to create those relationships with untagged VLANs and tagged VLANs on which ports. Yes?
So this happens seamlessly without user intervention so that optimize your network traffic.
What's that?
So you're doing this SDN to optimize network traffic, let's say by distance or between, based on throughput.
No, this doesn't optimize really anything.
So are you using network isolation to network isolate, or are you using SDN to sort of optimize the topology for it?
Yeah, this is just to allow, especially for legacy and migration systems, to allow them to control their own network topology, similar to what they would have in a physical environment. So in a physical environment, you'd have a real switch that had ports on it that were VLAN tagged or untagged on individual VLANs, access ports, for example, or trunk ports having a bunch of tags and an untagged VLAN. Instead,
So you're using this just to have a network somewhere?
well, to allow the user to control their own destiny. The administrator is not involved in this. They're not even aware that it's happening. It's just a regular VM that's running. As far as they know, it has a bunch of networks attached, and it does things with Ethernet frames that the administrator doesn't care about, but the user might, especially if it's part of a service where you're spinning up, like the Akamai guys may spin up an entire network stack. This, as part of that service, can act as a switch to segregate those things onto their individual VLANs and do coordination. If you had a DHCP server, you wanted to be on all your VLANs and not plug it in to all of your networks, you could use a virtual switch, or if you wanted to stand up an OpenNebula instance with compute and storage segregated by VLAN, this lets you get those tags happening.
Okay, so the questions in our two-fold question.
Mhm.
What's being compiled into when the user configures this?
Mhm.
He probably doesn't go into this level of detail. He might just say, I want a network that has these properties.
Mhm.
And these
Yeah,
based on the available
Yeah, usually it's software. The user of this is usually software. So there wouldn't be an actual human user. It's a piece of software saying, when to spin up this, the overall goal is to provide a service. So to achieve that service, I need a network topology that looks like this. So you can minimize the number of networks consumed by using VLAN tagging. You can meet your odd or legacy requirements, or you can help with migration by using VLAN tagging on top of the existing infrastructure. And usually, if you're spinning up a service that needs these things, you want it to be repeatable, you want your VLAN IDs to be the same. This lets you do that even if the underlying networks are different.
What's being compiled?
The configuration is being compiled. So this is the generic idiom. So in this case, the eth0 underscore VLANs equals blah, eth0 underscore native VLAN equals blah, and eth1 underscore eth2, et cetera. That gets compiled into an internal representation. And because we want to compare it to what's running, we want to know what's running, what's configured. If they're different, we want to apply only what changed. So if you change the native VLAN, we just want to apply that semantic change. So to make that comparison easier, we compile it into the same configuration as the original. That way their textual representations don't have to be the same as long as their semantic representations are the same or slightly different.
This looks a lot like the work we do at the Beacon project.
Mm-hmm.
You can apply for some European funding.
We might be able to contribute some stuff into the open source domain that this thing, the virtual switch for software-defined networking is very simple. It's really the most powerful thing that came out of it, besides being able to actually accomplish the thing I needed to do at the time, which was have my VLANs managed by me to get my tagging the way I needed it for my application, was this idiom of using OpenNebula user attributes, because that just saves us a lot of time in trying to define an API ourselves and trying to create an endpoint, and then when we have an endpoint, defining users and access control and rules and a way to manage users and access control rules. OpenNebula already provides that. We leverage it to have our own API inside of OpenNebula. All right, I think that's it for me. If there's no more questions.
No, thank you very much.
Thank you.